Hey guys, and welcome to GP Academia. Sa video na to, magpapakita ko ng sample problems in Taglish under ng Coulomb force and electric field topic. And we have this first example. So ito siya, given two particles with charges 2q and negative q. So some variable q respectively. The charges are separated by a distance r. What is the force experienced by both charges? So anong itsura niya? Ito yung itsura ng case na to. So ito yung unang charge natin, 2q. Then we have this negative charge, negative q. Tapos yung distance nila ay r. So paano natin isosolve to? Remember that kapag Coulomb force, at least may dalawang charges tayo na present sa isang system. Like this case. May distance tayo, yun yung important, siya yung magnitude ng charges nila. Note also that uh, Coulomb force, so force siya, so therefore vector quantity siya. Kung 2D yung case, therefore kailangan natin mag-component analysis. So first, we have this force on Q due to the presence of negative Q. And we can follow the formula of Coulomb force. So this is equal to K, yung unang charge mo. So that's 2Q, yung second charge mo, Q over R squared. Note na yung una nating kinukuha ay magnitude pa lang ng ating force na to, or force on 2Q. But we can see na positive siya, negative to. So therefore, we expect na yung force mo ay papunta sa right kasi attractive yung force na may experience ni 2Q mo kasi opposite yung charge nila. And therefore, this is your force or force vector on 2Q. So this is equal to positive 2Q squared K over R squared I hat. So nasa positive I hat siya or going to the right siya as shown here. Next, we have this force. This is force on negative Q naman due to the presence of this 2Q. So, paano yun? So, opposite lang siya given na attractive yung force na may experience niya. So, papunta sa left yun. And therefore, this is equal to negative 2 kq squared over r squared I. So, nasa negative I hat siya. Therefore, papunta siya sa left. Okay, next problem. Example number 2, the charges shown are stationary. So, ito yung itsura ng charges natin sa case na to. And we want to find the force on the 4 microcurie charge, this one, due to the other two charges. So, the other two charges natin, positive 2 microcoulomb. Then we have positive 3 microcoulomb. Then we have this distance, 20 cm. Then, itong angle na to ay 60 degrees pareha. So, isosceles triangle yung configuration natin. So, therefore, ano yung force na may experience ng charge na to? Yung una, yung force on 4, so this, yung force sa kanya, due to 2 microcoulomb, so this one. And yung force nila ay repulsive, given na positive sila pareha. So, therefore, papunta rito yung force na to. While yung force on 4 naman, due to 3, this one, ay papunta naman sa direction na to. Given na parehas din silang positive. So, repulsive yung force natin. Then, we can get first the magnitude of the forces. So, yung force muna on 4 due to 2, this one. This is equal to this. Note that your K here is equal to 9 times 10 to the 9 lang. Newton meter squared per Coulomb squared. And doing this or computing the value of this force, this is equal to 1.8 Newton. So next, we have this force on 4 pa rin due to 3, this one. And same method, makapag-calculate tayo ng magnitude na 2.7 Newton. Okay? So ngayon, alam na natin yung magnitude ng dalawang force na to or dalawang forces na to. So therefore, next step is find the resultant force on 4 microcoulomb given na vector quantity si Coulomb force natin. Okay, so after we get the magnitude of the forces, so we need to find the components of these two vectors. So ito yung una natin vector, 60 degrees along the positive horizontal or positive x. And then this one, f of 4 or the force on 4 due to 3. So 60 degrees with respect to the negative x-axis. And therefore, madali lang natin makukuha yung kanyang components. So for the horizontal component, makikita natin dito na yung shadow niya. So this one ay papunta sa positive x, yung isa ay papunta sa negative x-axis. And that is 1.8 cosine 60. Then for the case of the second force, we have negative 2.7, yung shadow niya along the horizontal, times cosine 60. Then for the vertical component, pareha silang positive, obviously, kasi yung shadow na kinakas nila along the horizontal. So that's 1.8 sine 60. Then we have 2.7 sine 60. Then we can get the summation of the forces along the x, along the y. Then we will get this one in order to get the resultant force. So this is equal to the square root of this quantity, yung summation of forces ng x squared, plus summation of the forces along the vertical, or y squared. Then you get the square root of that. Then you will get the resultant force, which is equal to 3.9 Newton. So yung magnitude pa lang yun. To get the angle, we can use this arc tangent, and given the summation of the forces or the components of the forces, then you will get about 83 degrees along the negative horizontal, or that is about 7 degrees with respect to the positive y-axis. Okay, and for the last example, we have this electric field. Given two particles with charges Q1 and Q2 respectively, find first the electric field at point X, this one, and the force on a negative 4.0 times 10 to the negative 8 Coulomb charge please at point X. So, yung unang case, wala muna tayong charge na pinlace dito. Purely, itong dalawang charges lang na to. So, we know na yung positive charge, this one, ay nagpo-produce outward ng kanyang electric field vector. Then, this one ay inward, given na electric field sink ang mga negative charges natin by convention. And we will use this test charge. So, let's say we have this test charge, certain positive point charge na arbitrary na ilalagay natin dyan. Kapag nilagay natin dyan yan, what we expect ay may repulsive pulse siya with respect to this one, or repulsive force na may experience dahil para silang positive, pero ma-attract siya papunta rito sa Q2 mo dahil opposite yung charge nila. And therefore, papunta sa right yung ating electric field, or iisang direction lang siya as shown here. And therefore, what we can do is to get the summation of the magnitude muna ng E1 and E2 mo. So, due to this charge Q1, then due to this charge Q2, or yung negative na charge na to. Then, you will get a magnitude of your electric field of about this one. So, about 9.0 times 10 to the 5 Newton per Coulomb. And given alam natin na papunta siya sa right, so positive I hat lang yan. And therefore, you have this electric field vector. Okay, next. What if we place a charge Q at point X? Kanina kasi kinuha lang natin electric field at this point. Now, kung may charge Q na tayo, madali na lang yan. So, given this formula, so F is equal to E times Q, yung E natin, yung electric field natin kanina, and yung Q natin, alam na natin yung value niya. So, therefore, multiply mo lang yan, at given na negative charge to, negative point charge, you will get a force of about negative 0.036 Newton. So negative sign, it means the force is directed to the left. And the force on a negative charge is opposite in the direction to the field.